Every year, an invisible force erases entire chapters of ancient ocean history from our planet. Beneath the waves, the very foundations of life are slowly dissolving, altering Earth's future irrevocably. The ocean, a vast blue tapestry, holds a delicate balance woven over millions of years. It is home to breathtaking biodiversity, from microscopic plankton to colossal whales, all interconnected. These marine ecosystems are not just remote habitats, they regulate global climate and atmospheric oxygen. For centuries, humanity viewed the ocean as an inexhaustible resource, a boundless provider. However, this perspective overlooked the profound and lasting impact of our actions on its fragile legacy. Think of the ocean as an intricate, ancient library, constantly being written and rewritten by life. Each coral reef, every kelp forest, represents a vibrant volume filled with invaluable ecological wisdom. But the acidifying waters now threaten to shred these irreplaceable pages before we can truly understand them. Scientists observe that the fundamental chemistry of the ocean is undergoing a dramatic, unprecedented shift. This transformation jeopardizes not only individual species, but entire oceanic food webs and their future. Understanding this crucial legacy requires looking beyond surface beauty into the unseen chemical processes. Our future on land is inextricably linked to the health and vitality of these magnificent underwater worlds. The story of the ocean's legacy is ultimately the story of our shared destiny on this blue planet. The primary driver behind this oceanic unraveling is humanity's relentless release of carbon dioxide. As we burn fossil fuels, much of this excess carbon is absorbed by the vast, thirsty ocean waters. This absorption sounds beneficial, like a planetary safety valve preventing even more atmospheric warming. But that's not the full story. This seemingly helpful process comes with a profound hidden cost. When carbon dioxide dissolves in seawater, it initiates a series of chemical reactions, fundamentally changing its composition. Specifically, seawater becomes more acidic, a phenomenon marine biologists call ocean acidification. Imagine a delicate antacid tablet slowly dissolving in a massive glass of soda. The ocean is reacting similarly. This increasing acidity reduces the availability of carbonate ions, vital building blocks for many marine organisms. Wait until you hear how this impacts creatures that build shells and skeletons from calcium carbonate. Corals, oysters, mussels, and even microscopic plankton rely heavily on these specific carbonate ions to grow. Without sufficient carbonate, these organisms struggle to form and maintain their protective structures, making them vulnerable. A leading marine chemist explained how future ocean conditions could make shell formation nearly impossible for some species. This isn't merely a slow erosion. For some creatures, it feels like their homes are literally melting away. Consider the tiny pteropod, a delicate sea snail, often called the sea butterfly, forming a crucial food source. Experiments show pteropod shells visibly corroding within weeks when exposed to predicted future ocean acidity levels. But that's not the strangest part. The problem extends far beyond just these calcifying organisms themselves. The decline of these foundation species sends ripple effects throughout the entire intricate marine food web. Fishes, birds, and larger mammals depend on these smaller shell builders for their sustenance and survival. For instance, salmon in some regions rely on pteropods, meaning their populations could face severe pressures. Many fish species also use chemical cues to find food or avoid predators, senses disrupted by changing pH. A marine ecologist noted that even subtle shifts in water chemistry can profoundly alter crucial behavioral patterns. This means fish might struggle to locate their prey, or even navigate their intricate underwater environments effectively. And then something unexpected happened. Even the ocean's ability to absorb more carbon dioxide is diminishing. As the ocean becomes more acidic, its capacity to take up additional atmospheric carbon diminishes over time. This creates a dangerous feedback loop, accelerating both atmospheric warming and further ocean acidification simultaneously. The ocean's immense heat absorption also plays a role, creating marine heat waves that stress ecosystems further. Coral reefs, already weakened by acidification, are particularly susceptible to these prolonged periods of elevated temperatures. They expel their symbiotic algae, a process known as coral bleaching, often leading to widespread reef mortality. A renowned oceanographer described these combined stressors as a perfect storm threatening marine biodiversity on a global scale. The legacy of the ocean's past resilience is being tested by human activity on an unprecedented geological timescale. It's like trying to rebuild a complex, Ancient Clark, while key cogs are constantly being removed or corroded, the intricate connections within marine ecosystems mean a breakdown in one area cascades into many others. The speed of these changes leaves little time for adaptation, pushing many species to their absolute biological limits. This ongoing oceanic transformation demands our urgent attention and a profound re-evaluation of our relationship with the seas. The ecological legacy of a healthy ocean directly underpins the economic stability of countless coastal communities worldwide. Millions depend on thriving fish stocks for food security and livelihoods, all threatened by these changes. Fisheries face substantial declines as key species struggle to reproduce and survive in altered conditions. Imagine a world where the vibrant colors of coral reefs are replaced by desolate, crumbling white skeletons. A marine biologist emphasized that lost reefs mean lost habitats for thousands of associated fish species. This biodiversity loss diminishes the ocean's inherent resilience, its ability to recover from future disturbances. Our planet's largest carbon sink is weakening, reducing its crucial capacity to mitigate global climate change. The ocean's regulatory role, maintaining stable temperatures and weather patterns, is slowly being undermined. The legacy we leave for future generations hinges on the health of these vital, life-sustaining marine environments. An expert in environmental policy highlighted that inaction today guarantees vastly diminished oceans tomorrow. Consider the potential loss of new medicines and biotechnological discoveries harbored within unique marine organisms. The aesthetic and recreational value of pristine coastlines and abundant marine life also suffers dramatically. You might not live by the sea, but its health impacts the air you breathe and the food you eat. This isn't an abstract scientific concept. It represents a tangible threat to global food chains and human well-being. The consequences extend far beyond the immediate marine environment, influencing terrestrial systems profoundly. We are witnessing a critical juncture where human decisions dictate the very future inheritance of our blue planet. The collective choices we make now will define the richness and vitality of ocean life for millennia ahead. This profound shift demands a global commitment to safeguard the extraordinary natural heritage of our oceans. The ocean's legacy of magnificent biodiversity and vital ecosystem services is undeniably at a perilous crossroads. Safeguarding these irreplaceable underwater worlds requires immediate, collective action to reduce carbon emissions and protect marine habitats. If you found this crucial story compelling, subscribe for more insights into our planet's most vital systems and share your thoughts below.